side. Well, later on. Okay, so that means under this part, they're going to check uses especially. Whereas for silicate, you need to know the types, how to draw them. Okay, so let's check. Silicon would be the element. Silicon, of course, is a polymer. Silicates, the compound. They all contain Si. Si lah. Okay, silicon. So briefly go through again, isn't it? Because at the very beginning, you are introduced to silicon. The second position element in group 14. Okay, so let's start with looking at silicon. Okay, of course, it is a semi-metal, or we call it metalloid. Okay, of course, nothing much to say. Silicon, of course, is a non-metal, or more precise, of course, semi-metal lah. Of course, forming a giant structure. Silicon connect to silicon. Okay, quite a giant. May not be 100% because semi-metal only. Now, of course, used widely definitely as semiconductors. Okay, in a small size, so be used as a semiconductor, which of course used in the integrated circuits, electric board lah. Okay, microchips, transistors. Okay, computer components, solar batteries. Inside, they all contain, or should I say, they may all make use of silicon as a semiconductor. Of course, I guess if you ever see a circuit board, isn't it? 电板, you're going to see a lot of all this. Okay, they're all, of course, transistor lah, semiconductor lah. Okay, all these things present in a circuit board. So of course, may not be all of them, but most of them, be made of silicon. Inside a solar battery, that means the circuit board inside. Okay, they all may contain silicon. And of course, since it is a semiconductor, half only, so you want to increase its quality, of course, especially in terms of conduct electricity. So there, the conductivity of silicon, of course, can be increased. You can improve it by two different methods, isn't it? One is increase the temperature. This one, of course, while you're using it, actually, this one is something which will take place automatically. Okay. The longer you use, the higher the temperature. So actually, silicon actually function better, when the temperature is high. Another one is by doping with, by mix with phosphorus and boron, which of course we assume as we add impurities to silicon. That means this one, of course, is important for at the very beginning, because when you start using it, the temperature is not so high yet. That means if it's just pure silicon, then that means at the very beginning, then the conductivity will be very, poor. Because semiconductor is like that, low temperature, not functioning well. So you want, your gadget to function well from the beginning until the end. So that means beginning, the function is helped by, impurities. Then as temperature getting higher and higher, automatic non-impurity also, the silicon already function very well. Okay, so there, how to improve the quality of semiconductor. Okay, besides, using as a semiconductor, okay, that means which presence in, all the circuit board and so on. I mean, part of a transistor also. Now, silicon, of course, also used in the making of silicon. Then, of course, silicon is a polymer. But because normally to us, polymer always, organic. Because normally polymer consists of carbon as the backbone. Carbon connect to carbon, like what you study last time, okay? It doesn't matter natural polymer like, natural rubber, where you study everything, the backbone is a carbon. Or synthetic polymer, or the plastic, of course the backbone also carbon. If carbon, that means there's organic lah. But for this one, that means the backbone is silicon, Si. So silicon, you need to know, is inorganic, So, but because that silicon is connected to like CH3 connect to OH, which are organic. So that's why polymer of silicon, we classify it as an organosilicon polymer. It means organic connect to Si, but Si is not organic. Si doesn't present in living things, so it's not organic. Okay, organic normally presents in living things. So, but it is connected to the part which presents in living thing. So organo. Okay, so silicon, well, used to make silicon, and silicon, of course, is a polymer. Right? So let's start with silicon, because silicon, that's all, it's a semiconductor, okay, which presents in a lot of electronic gadget. And of course, silicon also used to make silicon. So now let's have a look at silicon. Okay, so silicon, of course, is a synthetic man-made, synthetic organosilicon polymer. That means containing the Si, O, Si, O, Si, O, and no ending bonds. That means this one is the backbone, because Si similar as carbon group 14. So meanings, well, we would assume maximum it can share with 4 other atoms. So forming, joining with all the covalent bonds. Okay. So normally SiO will be the backbone of a silicon. Normally the backbone of silicon. Now, since Si can connect to 4 groups, isn't it? So there, on the left to oxygen, on the right to another oxygen, and then we assume on top and below, okay, that one will be connected to, all the organic compound, organic, groups. So R normally will be alkyl group. Now, alkyl group, of course, it can be anything with C and H. So if one C only, of course, you study, this is a methyl group. If 2C, of course, ethyl group, isn't it? Or of course, it may connect to a benzene ring, which is, we generally name it as an aryl group. Okay, a benzene ring, C6H5. Of course, all these are the alkyl group, the aryl group, of course, you will encounter when you go into semester 3. Okay, when you go to semester 3, you don't have a choice. That is the core of the semester 3 syllabus. Okay, so that means by right, silicon is inorganic, something to do with rock, okay, not present in living things, but it is connected to the part which presents in living things. So organol, okay, organosilicon polymer. Okay, so there are 3 common forms of silicon. Of course, the first one, fluid in liquid form. That means, for example, silicon oil, silicon grease. Okay, second would be the elastomer. That means the rubber, elastic type. It's solid form, but not so hard. Okay, that? And of course, the third is the resin. Resin is the hard type, hard solid. Okay. Just as when we said plastic, of course, some may assume it is elastic, like the rubber band. Or plastic can be very hard, like the chair you sit on. So that type is the resin type. So plastic will be similar. You get plastic elastomer type, plastic resin type. Isn't it? Because plastic also can be very hard, like the chair you sit on. Okay, of course, it can be, elastic, quite soft, like the rubber band or the eraser we're using. So silicon also quite similar, okay? It can be the hard type silicon, the hard solid silicon resin. Of course, it can be solid form, but it's, a bit soft, like the rubber type. And of course, it can be fluid, okay, the liquid type. Okay, of course, well, the same statement again. Silicon, of course, is used to make silicon. Now, of course, which one there? The tetrachloride. Okay, that means the silicon tetrachloride. So the chlorine atoms, that's 4Cl in the silicon tetrachloride, of course, can be replaced by hydrogen or replaced by methyl groups to produce, of course, substance which we call as a chlorosilane. That means silicon now, okay? Chlorosilane or maybe dichlorosilane or even dimethylsilane. Right? This one normally we say this is a chlorosilane because by right, silicon tetrachloride is 4Cl. So now let's say 3 of it already replaced by hydrogen. So chlorosilane or 2Cl dichloro and 2 methyl 2CH3. Okay. Of course, the correct shape should be tetrahedral for 2D drawing. Of course, nothing wrong. You draw them like this. So that means this is the starting of silicon. Of course, you start from the silicon tetrachloride. Okay, SiCl4. So you replace the Cl with others, then it will be the starting material for silicon, the monomer. Okay, so if you check, now of course more silicons are synthesized from the chlorosilane. Start from the chlorosilane. Yeah? So first you let it undergo hydrolysis. Okay, so hydrolysis of, normally you start from the dichlorodimethhyl, for example. Okay, so hydrolysis of dichlorodimethylsilane. That means you let dichlorodimethylsilane react with water. Then actually it will form a hydroxyl intermediate. That means the dimethylsilane diol. That means simple. Okay, we start from this one. This is only one unit. So now you want to make it into silicon. Silicon is a polymer. Never ending story. That means plenty. Don't know how many thousand units connect together. So how to connect? That means the first step, you let this one. For example, we're taking this one. Now, of course, it may not be dichloro. It can be trichloro. 3Cl, 1CH3. Right? This one, I put it 2Cl. 2Cl, that means normally you are able to get them as a straight chain. One long chain. So the first step, you let this one react with water. Hydrolysis, you let this one react with water. So when react with water, what happens? The Cl, this 2Cl would change to OH. Water, H2O, content of hydrogen and hydroxide, H and OH. So the OH would replace the Cl here. Right? So it will become a long chain. So that is hydrolysis of, let's say we use dichlorodimethylsilane. Okay, then you are going to form a hydroxyl. That means you're going to get a diol. Diol means there are 2 OH there. Okay, of course, eliminates water. Right? And forming a silicon polymer. So the reaction, first step, hydrolysis. So you see the Cl, this one, let's arrange it like this. So you see, so when react with water, hydrolysis means react with water. So you find that the Cl changed to OH. Okay, so water, H and OH, so the H will combine the Cl that was replaced just now. So of course the side product, hydrogen chloride. So this is the first step. So now this is the monomer for silicon. Okay, so that means now this monomer will keep on repeat. So the next step, of course, will be the polymerization. Now, of course, Don't tell me everything is an alien to you. Yeah? In Form 4, you study polymerization a little bit there because you study plastic then. Okay, synthetic plastic. Not to mention when you study alkene, you study again polymerization. So polymerization, there are two types. Huh? One is addition polymerization. Of course, the other one is condensation polymerization. The difference, addition polymerization, you keep on adding the monomer, then it getting longer, becomes polymer. That's all. Nothing is eliminated. That means when you add in from 1 unit to 2 units to 200 units to 2000 units, nothing is lost. It's just getting longer and longer. So addition polymerization. Normally means your starting unit, that monomer would contain double bond. So while you keep on add in, all the double bond gone, become single bond. That is a polymer, isn't it? So the second type, condensation. Condensation means when you add in the second unit, well, it will be connected, but at the same time, a small molecule would be eliminated. You need to get rid of like a water molecule or maybe like a HCl molecule. Then it can connect. Of course, also getting longer and longer. Condensation, polymerization. So that's it. There you start with 1 unit. So now you want to connect the second unit. Okay, that your diol just now. This one, that means your dimethyl, isn't it? Okay, dimethyl, silane, and then you get diol. So that means for this OH connect to this OH. So you need to get rid of a water molecule. Let me imagine H gone, OH gone, then it will connect. Then you get the SiO. And so now 2 units, of course you can continue. Now let's say I add in the third unit. So same thing, that means here for the OH and this OH to connect, you need to get rid of a water. Then it will connect. See that? So that means the process on and on. So polymerization. So of course you can control. Of course in industry it can be controlled how long they want it. Get that? So this one, that means you get a straight chain. So if straight chain normally means it would be the fluid type, liquid type. You want it to become solid, then of course you need to make it, having a few layers, cross-link. Okay, just as when you comes into rubber, you want to make it into vulcanized rubber, isn't it? Cross-link them. But this is the basic idea. So that means as a summary, isn't it? Okay, so of course for condensation, normally we don't have to write, let's say 1, 2, 3 and so on it lah. General. 1 units become plenty unit with an N lah, isn't it? Okay, with an N. Of course, with the elimination of water. So that means basically the formation of silicon involving 2 steps. The first step is the dimethyl dichlorosilane undergoes hydrolysis. Then the product from there would undergo condensation polymerization. Okay, Now, since there are no carbon atoms in the backbone of silicon polymers, so silicon, of course, is an inorganic polymers, okay? So that long chain. And then SiO. So that is the backbone of silicon. Okay, the length of polymer, how long you want it to be, of course, can be controlled by adding a calculated quantity of monohydroxysilane. Monohydroxysilane means contains only 1 OH. Just now we get diol. Okay, that means just now our starting material contain 2 OH. See that? So of course you want it to stop, then you add in another type of monomer which contain only 1 OH. That means let's say contain 3 CH3 lah, only 1 OH. Okay, so of course it can be controlled. And that. Now, of course, if you start with trihydroxysilane, that means 3OH. When you add them to the polymer, then you find that cross linkages between polymers will form. I mean, we add 3OH, get that? Trihydroxy. Now, of course, you should know that when OH act, okay, as a functional group, more or less a functional group, yeah? Now, last time, of course, you may said, oh, the name all become OL, alcohol, but that is when one OH. When it is a lot, normally the name given to it is hydroxy. XY, yeah? Okay, that's trihydroxy. Of course, in terms of naming later on, when you comes into from semester 3, you have to know how to name them. Okay, so that means, of course, with the starting, it will be simple. You just make use of this one. Okay, the dimethyl, what's the name just now? Dimethylsilane diol. So you start with that one as a monomer, then it will keep on, getting longer and longer and longer and longer. Isn't it? Now, if you want to stop it, then you add in a structure which contains only one OH. You add in monohydroxysilane, then of course you can stop the polymerization. That? And if you add in in the trihydroxysilane, you make your polymer from one long chain. Now it becomes cross linkage. Then that means you can make layer and layer and layer to it. Okay. So 还有一个丁中玉，快要半个钟了啦，我要 call 他一下吗？So you extra phone with you now? Try to call him. 不然的话他就要写信了哦。无缘无故没有出席。Okay, so this is what we call as a cross link. Now, of course, you should know when it is one straight chain only, of course, it's soft, elastic. More or less, we said normally that would be fluid form. If the cross linkage like this, the cross link limited. This one quite limited. You see the cross, so would be elastic. If you get it more layers of cross link, then of course it will become very hard. Okay, that's how they form the silicone today industry. So I mean briefly, there you start from let's say you start from the trichloro, isn't it? Just now we start from dichlorodimethyl. That means you assume your R is a CH3 lah. So if you start with 3, isn't it? Then of course first hydrolysis, then they all change to OH, and then this OH keep on getting longer and longer and longer polymerization, isn't it? Then it becomes a cross-linked silicon. So far, I think this knowledge, okay, so far, no question asking you how, or should I say no question ask you to write equations so far. But we never know, because this is something which you're supposed to know. How to produce silicon, okay? Of course, silicon polymers, of course, will become viscous when the chain length increases. That means the longer the chain, of course, it will become more sticky. Viscous means getting less watery, okay? Become, sticky. Become slowly, become solid lah, okay?
终于嚟啦！
哎呀，总是要比别人慢上半个钟啊！人呢？快叫大家呀！Okay, so let's see, 3、4、5、6、3、6、18. Is everybody here? Let me check 3、4、5、6、5。哎呀，你两个看不到脸。Okay. down. Hey, hold on now. Let's stop first. I need to get your proof. Hey. Oh no lah, all this 10, 14, and then 3. Kahong why your icon no picture leh? Gelap saja. Huruf pun tidak ada. Mana?哎，迟到的两个干嘛迟到？又是睡不醒啊？
睡觉睡觉。
杰森呢？一样。哎。This is when you don't have to go to school. You imagine you need to go to school 啊？你还不是要5点就要爬起来？5点半。
我很早起来了，只是躺下去就睡着了。
哎，啊 ，Of course, going back to school 哎，don't ask don't know. Okay, let's continue Okay, so that means silicon, of course, silicon polymers, okay, become viscous when the chain getting longer, and then it becomes hardened, okay, from a liquid form, oil, to rubbery solid, and then eventually to resin when the cross linkages increases. Okay, more layers connected, then of course it's getting harder. From elastomer, from steel elastic becomes something which is hard and strong. Okay, unlike natural rubbers. Natural rubbers also something like that, but it consists of C and H only lah. Okay, or even the synthetic rubber. Now, comparatively, properties of silicons are not affected by chemicals. Lubricants and oils not affected by oxidation, I mean not affected by ozone, not affected by UV light, no need to worry about fungus, not affected by temperature also, high or low has no effect, and also it is water resistance all the time. That means all these properties are not affected in silicon compared to natural rubber or synthetic rubber. Because make it very simple, natural rubber definitely affected by temperature. Okay, in fact, that is a weakness of natural rubber. When hot, it becomes soft and sticky. When when cold, it becomes hard and brittle. That is a weakness of natural rubber. Okay, and then of course, natural rubber also under oxidation. Then of course it will turn into brittle also. Even synthetic rubber still have that problems, isn't it? Imagine like your a rubber hanger. If you always expose it under sunlight, then of course you find that it will turn into forming the powdery, and then eventually it may become so brittle that it just crack like that. Okay, so that's the weakness of rubber. But silicon, no such problem. That's why sometimes silicon is should we say more safe to use, or should we say it lasts longer. Okay, should we say normally the most should we say properties which make silicon much better than the other types of polymer would be silicon, that means it's inert, that means not affected by any chemicals, no need to worry about acid, no need to worry about alkaline, and of course silicon non-toxic. That okay, so if we check, so what way do we use silicon? What is the major uses of silicon? Okay, now silicon first to make sealants. Sealants means like the glue, that is sealants. Okay, for glass, for ceramics, or even for metals, okay? In building and also maybe in household parts. I mean like the super glue lah, okay? But of course silicone is not the super glue. The component is slightly different, but silicone lah, okay? That means the strong silicon oxygen bonds in silicon, of course, makes it resistant to chemical corrosion. Okay? That means normally I think normally is white color, isn't it? Or sometimes it is colorless actually. Kind of like glue lah, okay? You put it there. Of course, the major advantage because it's waterproof. Okay, second, use it as a lubricant. Minyak pelintir, okay? Or hydraulic fluids, okay? In high temperature equipment because it is stable to heat and also stable to light. Okay, 润滑剂. Yeah, silicon fluid or silicon oil as a lubricant. That. And of course, if let's say your gadget is very small, then actually you can spray it also. So the lubricant can be in spray form. You want to lubricant a small part like a lock, okay? Sometimes your lock if a wet all the time, then it might rusted already, okay? Then well, you can lubricate it, okay, using silicone oil. Okay, number 3, silicone in elastomer type. I mean in the rubber type. Okay, you can use it to make surgical implants, okay, in plastic surgery because it is non-toxic. So even let's say put inside body also, you don't have to scared it may harm, or it may become toxic to the body. And okay, surgical implants. Of course, surgical implants sometimes may not be, should we say, not because you want to make it look more attractive, but sometimes due to accident. Okay, I mean, let's say you lost part of your flesh. Okay, 整块肉不见掉. Of course, you need to feel that part, or it may look ugly, or it may make you look weird. Then, of course, how to fill in? Fill with silicone. Okay, but of course, one of them there. I guess normally when we talk about plastic surgery, I think most of us getting the impression this one. That, but you need to know this one breast implant, not just how should we say, not just because let's say want to make it looks larger in size, but sometimes due to medical should we say requirement. Let's say for those who are having breast cancer, and then of course you have to cut the part. Then of course you need to put back something, isn't it? Of course, may not be put in a silicone gel, okay? But this is one of the method can be used, okay? Because I guess nowadays plastic surgery is not something very uncommon. Okay, you definitely heard of there are other methods, right? For example, let's say for those who are having breast cancer, after you cut, your breast, then of course you need to build in something so that it looks normal. Okay. Of course, nowadays there's a choice. Another choice is they are going to cut flesh from other part of your own body and then to fill in there. But still, the size may not be as you wish. So sometimes, well, a breast implant would be one of the suggestion. Okay, so can make use of silicone gel because it is non-toxic. Okay, and also if it is in a sheet forms, of course you can use in scar treatment. That means it can act like skin, okay, because it is non-toxic and then it can be cleaned and can be reused. So normally they can put it there. When you have burn scar, especially, let's say, to help the healing process faster, okay. Of course, this one is for when the surface area is so big. When the original skin is burned, exposing the flesh under the muscle under it. If you just straight away cover using like bandage, because there are fluid will be released. You see, that means you get the should we say the body fluid lah. Okay. Then if you just cover using bandage, then the bandage may stick to the muscle here, to the flesh. Then actually, when you want to change the bandage, of course, that is torturing. But if you don't cover, then it will expose directly to all this virus, all this bacteria, and so on. That won't be helping the healing process. You cannot cover with anything like plastic, because plastic is impermeable to air and also to liquid. Then that means the area covered, if you are using any plastic, then that means it will be wet all the time. Then it's not good for healing process. So they can make use of silicone. Okay, because in this case, that means you can reuse it, you can clean it easily. One of it lah. Okay. Now, silicone oil, of course, also used by physicians, okay, to treat diseases, like retinal detachment in the eye. Okay, they can apply this one because it has the effect like glue, isn't it? Okay. And then, of course, silicone rubber, okay, of course, generally non-reactive, non-toxic, stable, resistance to extreme environments, resistance to temperature, isn't it? In fact, silicone, all physical set having this character, okay? If you check the rubber, so they can be found in a wide variety of products, like you use them to make automotive applications, okay, like hose, or use them to make cooking or even baking and food storage products, container, okay, even use them to make clothes, okay, like maybe in the undergarments, okay, undergarments or your underwear, okay, or even in some sportswear, shoe, okay, cloth, okay, footwears, okay, because it is waterproof. So they may all contain silicone. Of course, it can contain rubber lah. Contain PVC from what we study. That means PVC compared to, for example, hose or pipe made of PVC compared to made of silicone. Of course, you need to know silicone not affected by oxidation, not affected by temperature. So that's the advantage compared to PVC. Because PVC is still rubber, still plastic. So it may still affected by oxidation, especially. Okay? So that means comparative lah. It can be made use of the same material. All these hose, isn't it? Okay. Then of course that can be PVC. Of course it may also be silicone. Okay. Or the cooking, the baking molds. Okay. The footwears, shoe cushion, even the key, the knee pad, the shoes, of course, they all can be silicone, or of course, they can be rubber. Who knows? Okay, plastic. Now, silicone resins, of course, normally can be used as an insulator. Okay, for wire castings. Okay, for pot holders. It can be silicone. Okay. And of course, since it's waterproof, so silicone fluids also can be shoe shines, car polish, because it won't wash away by water, isn't it? So of course, they all can be containing silicon in fluid form. Okay, there even a bread fluid also can be. Okay, because bread normally always under high temperature. So you use silicon, of course, because silicon, not affected by temperature. That now, of course, solid silicons, elastomer normally lah, yeah, also can be used to manufacture feed bottle tips, okay, or even pacifiers. That okay, feed bottle, bottle susu, nai ping lah. Tits, of course, the how should we call it? Tits lah, nai chui lah, yeah. I mean this one, no, isn't it? What do you mean by pacifiers? Yeah, pacifier normally for who? Normally, pacifier is for who to use. It's quite similar as this one. Everybody have one when you when you were kids last time. And then pacifiers. Okay, so of course all this, yes, it can be made of plastic, but of course it may also made of silicon. So if you really want to do comparison, silicon may be better lah. After all, one of the very obvious character of silicon is it is non-toxic and not affected by temperature. Compared to plastic, of course, normally plastic we always assume it's not good to use under high temperature, isn't it? Because it may affected by high temperature. Okay, so there, silicon. So silicon, of course, books normally focus a little bit on, you need to know some of the uses. Okay, and the process, more or less know a little bit. Okay, that silicates. Silicates, of course, is a compound. Okay, so silicon, of course, forms a strong bond with oxygen. So that means it forms a class of compounds with oxygen, which of course we call them silicate. Silicate means contain Si and O. In, of course, in a giant structure normally lah. Okay, so that means what do you mean by silicates? They're compounds containing silicon and oxygen. That is silicates. That means silicon just now is a polymer. Okay. So this one, well, it's a compound. So of course, silicon normally naturally exists, okay, as a silicate, which we're going to study here. And then of course, silicon also may present as a SiO2 only, silicon dioxide. Okay, and of course it can be that all these aluminosilicates, they all contain Si. Function, of course, different. Okay, uses different. They all would be silicates. They all more or less contain Si and O. Okay, so we are looking at the first one. Silicates. Okay, silicate accounts for over 75% of the minerals in the Earth's crust. They all contain SiO. I mean, in sand, it's a silicate, okay, or SiO2, quartz, asbestos, clay, all this mineral. So the basic unit in all silicates will be SiO4 in a tetrahedral shape. Okay, SiO4 charged for negative. Or of course, when you look top view, isn't it? Because your O, so Si, is covered under O. So it's very common when we are talking about silicate, we always get this type of drawing. When you study silicates, you need to prepare, you need to know how to draw. So there are 4 oxygen, 1, 2, 3, 4, one on top, right in the middle, and then the Si is right below the oxygen. Okay, so there. Okay, so that is silicates. Okay, so that means we're going to look at silicates. Okay, because there are how many types there? 3 types, huh? They all contain Si and O. So we are looking at silicates now. These 2, I think we only able to did them on Monday, huh? Okay, so now silicate is classified based on how the tetrahedral units are arranged. So there are, well, 6 different types. You get autosilicates, pyrosilicates, ring silicates, chain silicates, sheet silicates, and framework silicates. Okay, that means getting more complicated, getting more layered. Okay, framework, like 3D structure. Sheet already, a few layers. Chain, of course, you should know a long chain, isn't it? Ring, forming at least a triangle, a hexagon and so on. Auto pyro, of course, you should think they would be very simple lah. So how do they arrange that? We'll put them under which category? And of course, there's been question come up where you need to draw them under this different arrangement. Oh, of course, you may have a look like this. Okay, the primary type talking about these 3. Okay, autosilicates, pyrosilicate, and ring silicates. They're the primary type. And then you get the chain. Of course, there can be 2 types. Okay, pyroxene and amphiboles. Okay, that means chain, single chain, double chain. And then you get sheets. The example will be, mica and tau. This one I think is wrong spelling. Sorry. Talc is a TALC. Talcum. And then framework, of course, normally we're talking about this 4. They are in a 3D structure. Okay. And out of all this, of course, quartz, feldspar, they're all rocks. Clays, material used to make ceramic. Zeolites, of course, act as a catalyst, which, of course, we're going to study later on. Okay, so let's have a look at this one. Okay, let's look at the primary type. There are 3 examples, autosilicate, pyrosilicate, ring silicates. Okay, autosilicates, or the common name neosilicates also can. The simplest, containing, SiO4. And of course, normally autosilicates have high density, high refractive index. Means they look shiny. Okay, they can, reflect light. Normally used as a gemstone. Okay, so the example topaz. Okay, phenixite and zircon. All this actually, like topaz, you should know, this one, of course, is a gemstone. Okay, 宝石来的. So zircon also, I think, normally we said what? Fake diamond. Okay, because this one, you can cut, and then it has a so high refractive index that it's, reflects light, so it looks really like diamond. Okay, so that means that is the simplest type, contain SiO4. Discrete, that means SiO4 alone, just 1 unit like that. Okay, so there, topaz, you see, SiO4, only 1 unit presence in a structure. Okay, so, gemstone. Okay, then you get this one. Okay, the phenixite, SiO4, 1 unit only. Of course, it can be the zircon containing, the zircon. Okay, it can be cut and made to look like diamond. Okay, so auto, that means only consists of 1 unit, the discrete SiO4. Okay, next, pyro. Pyro, that means 2 units. 2 units of SiO4 joined together by sharing 1 oxygen atom. See that? That is how you, that means, or maybe normally we don't draw this way. I always said we draw this way. Okay, that? So it consists of 7 oxygen, 2 silicon. Okay, that means it's a Si2O7, charge 6 negative. Sometimes like it or not, you have to know it, because there has been question come out. That means the unit is an Si2, the formula lah, Si2O7 with a charge of 6 negative. They share 1 oxygen. See that? Okay, so the 2 examples, okay. If you ask me how to pronounce also, I may not pronounce it correctly. You pandai pronounce sendiri lah, ha? Okay, so the 2 example. Of course, they're all rocks, okay? To us, they look like, they look like rocks, that's all. Okay, so you see there, Si2O7, okay, this one contains zinc, Si2O7, see that? Okay, hemimorphite contains zinc. This one, torvitite, contains scandium Sc. Why is yttrium? Okay, so that is pyrosilicate, 2 units combined. Okay, ring, cyclic type. So it is formed when each tetrahedral unit share 2 oxygen atoms. So the most common, of course, composed of 3 tetrahedral forming triangular, okay, triangular rings, as in benitoite. That means the simplest lah, 3. So they are going to share 2 oxygen atoms. This one, the simplest form. See that? 3 units joined together. So they share oxygen. Okay? How many oxygen is that here? 2 oxygens. But this one actually they share 3 oxygens already. That means the simplest lah, they will share 2. Because they need to form a ring. So 1, 2. So this one, that means this is the formula. Okay, that means the simplest is this one, S3O9. I mean, they are sharing, how many here? Because 1S, yeah, that means here is 3 oxygen, no? Because 1S is 4 oxygen, yeah.
干嘛是 SM 不是 SI 呢？
Oh, sorry, SI, not S only, SI. Sesat now, the I hilang. SI, okay. So the simplest will be 3, at least 3 lah. Because the simplest ring is a 3. Okay, so Si3O9. Because by right, if 3 Si, that means there should be 12 oxygen, no? Because SiO4, so this one sharing 3 oxygen, If they do not form the ring, of course they share 2 oxygen. Now you imagine if they're just a straight line, isn't it? A straight line, that means 1, 2. They share 2 oxygen, no? But if you want them to form a ring, that means, they're going to share 3 oxygen. 1, 2, 3. So it's an Si3O9, okay? Okay, so that benitoite is used as gemstone also. Okay, contain what? Barium, titanium, okay? Then Si3O9, see that? Okay, so that is the simplest triangular shape. 3 silicate combined together. The simplest form, okay? 3 silicate. So of course this one, it all depends on how you cut them. Then of course but you cannot deny that of course all of them having high refractive index. That means if you cut them at the correct angle, they can reflect lights. That's why they look shiny, okay? Gemstone. Okay, so primary type, 3 types, settle lah. That, so I guess we do until 3 types. Actually, the rest, of course, for this part there, I dare not say. Of course, the question is not popular, but there's a big chance that it come out in a small part of a question where they may ask you, regarding the formula. That means they may ask you about this. So if you know, of course, you score your marks so easy. But of course, undeniable, you need to remember a lot, no? OK，你背了，它不一定会出。可是如果它一出呢，它可以是很简单。They will ask you what is a unit, the unit formula for ring silicates. I mean this one, Si3O9 6 minus. Normally they definitely asking about this one only. Or if the pyro type, pyrosilicate, I mean it will be the Si2O7. That charge 6 negative. So of course I dare not say anything lah. This one simple lah. SiO4 4 negative. That's all. Because there are 6 different types. So whether you want to take the risk, okay, try to remember. We never know, okay, because it may not be asked at all also, because it's really just a small part lah. Okay, I think we still can proceed lah. Okay, Chem, okay, or another term is inosilicate. Just now the auto is the neosilicate. This one inosilicate. Okay, 2 important types. The chain, single chain or double chain. Okay, there the repeating unit would be SiO3 for single chain. And that, the term just now, the repeating unit. So repeating unit for autosilicate, SiO4. In fact, no repeat because it's a discrete SiO4, 2 negative. When you come into pyrosilicate, the formula is Si2O7, charge 6 negative, isn't it just now? And for the ring silicate, the simplest is Si3O9, isn't it? So now this one, because chain means a long chain. So the repeating unit for single chain, SiO3. And the repeating unit for double chain, Si4 or 11. So that means the so-called, the repeating unit, of course, is fixed, which, of course, as I mentioned, you remember, you straight away score the marks. You do not remember, I don't know, you can try to draw and see whether you can figure out. Okay, now, single chain, of course, one of the example, pyroxene. Okay, it's a single chain, Remember, pyrosilicate is 2 units, so pyroxene is a chain. Okay, it is formed when 2 oxygen atoms per unit tetrahedral are shared. Similar just now. I mean, pyrosilicate, 2 units share 1 oxygen. So similar, 2 units. This one 2 oxygen being shared because pyroxene panjang so kiri kanan being shared, forming 1 single bond, a single chain. Okay, so the tetrahedral, of course, are arranged in alternate position to the left and to the right along the chain. There, alternate, atas bawah, atas bawah, atas bawah. This one bawah, atas bawah, atas bawah, atas bawah, atas. So you see, they share 2 oxygen atom. Here 1, here 1. Or if you are looking at this one, here 1, here 1. 1 unit, 1 unit. So sharing 2 oxygen. So one of the unit is SiO3. It's counted 3 only, because 1 already shared. We assume actually 2 being shared. Okay, so that is how it is being arranged. Single chain, alternate, left, okay, on the left and on the right. Atas bawah, atas bawah, atas bawah. Okay, of course the complex chains may be spiral, but normally don't draw spiral. If they ask you to draw straight chain. Okay, draw it straight like this. So of course the example jadeite and dioxide. And this time you look at the word JADE, you should know already, jet. It looks green in color. Contains sodium, aluminum. Okay, calcium, magnesium. Right? So this one is Si2O6. That's the repeating unit. There, SiO3. So here, of course, only showing 2 units. Also there, the jadeite. Okay, contain sodium, aluminum. Isn't it? Okay, and you get dioxide. Okay, looks quite similar, of course, to us. They look similar. 真的丢一堆给你，你也看不出。Okay, that means this one because they are not being cut, not being polished. So of course, they don't really look that shiny, isn't it? Of course, this one being polished. So this is pyroxene. Single chain. Okay, and then amphibole will be a double chain silicate. Okay, it is formed when 2 pyroxene are joined by sharing another oxygen atom. You see, one on top, alternate bawah, atas, bawah, atas, bawah, atas, one on top. And then satu lagi bawah sini. Atas, bawah, atas, bawah, atas, bawah, atas, bawah. See that, isn't it? So you join together there by sharing another oxygen. So this is double chain amphibole. Okay, just now single chain pyroxene. So this one double chain amphibole. Okay, or you prefer like this one, isn't it? There, double chain, one on top, one below, alternate. Atas, you know, this one atas bawah, atas bawah, atas bawah. This one is bawah, atas, bawah, atas, and then they join, sharing another oxygen. Okay, in amphibole, some of the silicate units share 2 oxygen atoms, okay, while others may share 3. Get that, yeah? To form a long linear chain of hexagonal ring structure. There, so the forces holding the chains together are weak. So amphiboles are brittle and break easily. Okay, this one now. So some sharing 3 oxygen, some only sharing 2 oxygen. Okay, like this one, sharing only 2, isn't it? This one sharing 3. Okay, the most common amphibole will be asbestos. Okay, it is strong but brittle. Okay, 很硬可是很脆。Of course, it's cheap and then resistance to heat, resistance to acid, and also alkalis. Like that. So that is asbestos, a type of amphibole, double chain. Okay, hard, looks like rock but quite brittle. Okay, so of course asbestos is used extensively as heat insulator and also brake pads. I don't know this one, brake pads. That means when you, put on your brake, so this one would cause, the wheel to stop. What do we call it? Rotating, yeah. Don't ask me. I don't know where it is. Somewhere here, lah. Okay. And this one now, heat insulator. That means this pipe. Of course, I don't know because we never go into construction except any of you having experience. Our country maybe not obvious, God, because this one normally they say you want to the pipe which use it to channel heat into building. Because like some country with winter, then you need to make the whole building hot. Of course, you need to channel. We are going for aircon. We go for cold air. But during winter, you need to put hot air. So of course they are channel into or using pipes also, isn't it? So of course the pipes will be very hot, you see? So that means they are going to covered by insulator. Of course, normally it's made of asbestos, heat insulator. And so you cover around the pipes. So normally it's made of asbestos. Okay. Now asbestos cleaves easily in the plane parallel to the chain. Okay, so they can form fibers easily. Okay, but of course asbestos dust is extremely hazardous, can cause lung cancer suspected or tuberculosis. Okay, penyakit TB, 肺痨. Okay, so asbestos is a type of double chain silicates. Okay, and then the layer type, okay, the sheet silicate. Of course, it is formed when each tetrahedral unit shares 3 oxygen atoms. The structure are similar to amphiboles, except the hexagonal ring structures extend in both directions. Okay, to give an infinite 2-dimensional sheet structure. The repeating unit Si2O5. I mean this one. So you see many layers. That's all. Just now because only double chain. Amphibole, the example is asbestos. It's only double. This one it can be, you see a lot layers. So that is, sheets. The layer silicates. Okay. Normally we don't bother about 3D because 3D is very hard to draw. Just look at 2D enough. So this one, how many chain? 1, 2, 3, 4. 4 chains combined together. Okay, because asbestos, the amphibole only double chain. This are more than double, then it becomes layer chain. See how many layers here? 1, 2, 3, 4. 4 also okay, 4 layers. Normally that's how they draw. If in exam they need you to draw, do your own practice. Don't ask me. Okay. Now, of course, weak van der Waals forces holds a silicate sheets together. So the sheets can slide over one another easily, making sheet silicate soft and slippery. So example, normally mica and talc. Talc, normally that means another simple version to us, to make talcum. 爽身粉. So that means they are slippery, 很滑很细. So that is layer silicates, okay, the sheets silicate. So, of course, all this to us rock rock. So the example of layer silicates, like mica, like talc, or even clay, okay, or even 自己背一下 or if question ask for example, don't use this one ya baca pun sudah susah. I use mica and talc. Okay, collinites. I mean this one is clay, 粘土. Okay, morillonite. Don't know how to read this one. Okay, so that is a layer sheet silicate. Right? Okay, mica easily cleave into thin transparent sheets. Okay, that means you can cut them easily. It has high electric strength and is chemically inert. Used to make capacitors for radio frequency applications. Also used as an insulator in high voltage electrical equipment. It is resistant to heat, so it is also used in place of glass in windows for ovens, stoves, and kerosene heaters. That means it is transparent, so it can replace glass because it is resistant to heat. Because sometimes glass still, some glass may melt under 1600 degrees Celsius. So window for ovens must be something which can withstand very high temperature, and yet it should be transparent. So it is made of mica. Okay, Talc, okay, is a mineral composed of hydrated magnesium silicate, contain magnesium silicate. Okay, the major component in talcum powder. Okay, bedak. Let's call it 双身份 Okay, so that is sheet silicate. So imagine 双身份当然是石头磨出来的。Okay, 所以那一种石头类它就要有that means it is actually consists of sheet silicates. Okay, the last type. Let's settle this one. Framework silicates, or we call it tectile silicates. Okay, it's a 3D structure of SiO2 where all 4 oxygen atoms per unit tetrahedral are shared. So in the giant structure, each silicon atom is bonded to 4 oxygen atoms and each oxygen atom is bonded to 2 silicon. So normally the example quartz, feldspar, okay, tridymite and cristobalite. So there, giant structure. Each silicon bonded to 4 oxygen, each oxygen bonded to 2 silicon. That means the structure just like diamond. 3D, yeah? Except diamond, all will be consist of carbon. This one consists of 2 types. You see, that means it's 3D structure. All the atoms are shared. Okay, or this one you imagine like you view from top lah. Want to say top also no. Because if top, that means your O and Si will be overlapping each other. But this is in a 2D, in a 2D way lah. That means the SiO4 is not like in the cross, not like in the 4 direction of, 东南西北, not in the direction of like east, west, south and north. But it is, like this like in X lah. Okay, SiO4. There. Si connect to 4 oxygen and all the 4 oxygen also share to another Si and Si. Okay, so that is framework silicates. So of course present in quartz, tridymite, okay, cristobalite and also feldspar. Semua itu of course batu. But this one, you look at the structure, you already know it is very hard. Quartz, of course, one of the hardest rock that we have there. 硬石很硬的石头 Okay, so that, okay, quartz, tridymite, cristobalite, can't really see and you go and search. Okay, I mean they're all rocks okay, so quartz, okay, pure quartz actually clear, colorless, transparent,